Okay, first thing I'm going to talk about is significant figure. Whenever you're in science or engineering and you measure with someone, not by definition, you measure, like you're weighing something, you're finding the length of a side of a box or whatever. There's error built into that. Significant figures will help you with that. So I want to talk about how do you calculate what a significant figure is. So it's a measurement of precision. And that's what this says. Measurement of precision. So we've got all kinds of numbers. Some have decimal points, some have zero, and they're going to vary. Now, from this moment on, for the rest of the semester, we're going to be using significant figures, or sig figs or SF. So, on a test question, you get the setup correct, you get 90% of the points. If you get the answer, you get 10% of the points, assuming the units are correct, significant figures are correct. So if the problem's worth 10 points, 9 points are for setup, 1 point is you know how to use your calculator. Okay? The setup is where the chemistry comes in, not how to use your calculator. Okay, so let's go through these here. We're going to create a rule right now. Okay, so the number 1, 2, 3. How many? Who's had sig figs before, like in high school or something? Okay. All right, quite a few. That's good. By the way, my assumption is you've had none of this stuff. I'm starting from absolute scratch. Okay, so if you didn't raise your hand, that's fine. It's fine. Or if you had it 9 years ago or something like that, it's fine. Okay, so for the people that did not raise their hand, how many sig figs do you think the number 1, 2, 3's got? Take a flying guess. 3. Okay. What about 100?
Okay.
3. What about 100 point?
Still three.
3. What about 101? How about 0.0031? 5.
This representing again?
Huh?
What is this representing again?
Significant figures.
Ah,
And again, whenever you measure something, you have to take into account significant figures. Okay, what about the next one down? 0.3105. What about 0.3100? This is getting boring. How about 1.102 times 10 squared?
five.
Okay, so I'm going to circle the correct one. Okay. So the first one, 1, 2, 3, 3 sig figs. Question. Next one down. What? Notice the difference between the first 100 and the second 100, what's the difference? Decimal point, all right? Okay. Star that in your mind. Okay, the first one, there's no decimal point. So that means the trailing zeros don't count ever. Okay, the second one, the trailing zeros count because of the decimal point. 1 versus 3. Okay, we have a 0 again on 101. That's in the middle. Middle zeros always count. They're placeholders. 0.0031. Beginning zeros never count. So it's 2 sig figs. The next one down, we have a beginning 0 and a mid 0. The mid 0 counts, beginning doesn't. So that's 4. Now you're going to be practicing this a lot in dry lab today. Okay, we have 0.3100. We've got trailing zeros with a decimal point and beginning zeros. Beginning zeros don't count. Trailing zeros count because of the decimal point. Doesn't matter where the decimal point is. The zeros at the end will count if there's a decimal point. Scientific notation numbers, only you look at this. You don't look at the exponent. So that's 3 sig figs. So there are rules now. The rules apply to zeros. Okay, so beginning zeros never count. No exceptions. Middle zeros always count, no exceptions. Now the issue are the trailing zeros. If a decimal is present, they count. If no decimal, they don't count. Now, notice I put 0 points here, 0 point, 0 point. Always do that if the number is less than 1. The reason for that is sort of a medical reason. In hospitals, when they used to take medical records by hand, there were some people lost their lives because of a mistake with a decimal point.
Still
Hmm?
happens. It still happens. So you have to write it specifically, so like now you can't say 0.5. Say it was slash 2.
Good, I didn't know that. Thanks for sharing it. You work at a pharmacy? The one for county.
I'm a legit drug dealer, yes.
Okay, so in dry labs, you'll see the 0 in front. And I want you to get in the habit of doing that. I'm not going to mark off for it, but it's a really good habit to get into. Okay, so 3 situations. Beginning, middle, end. Beginning, they never count. Middle, they always count. End, it counts only if there's a decimal place. Now, in your dry lab, whenever, if we have, the answer to that is 1, but your dry lab will give 2 answers. They'll say 1, and the other one is not sure, or something like that. And math people do this all the time. They'll say, well, you can't tell the number of significant figures on that. Yes, you can. You do it for the least significant number that number represents, which is 1 significant figure. But you can't do anything if you don't know, if you can't work with the number. That's the math. I used to be a math major when I went to Davis as a math major. Totally unpractical people. It was crazy. When I got into abstract algebra, that's when I decided math is not my thing. And I became a chemist after that. Okay. Okay. When we know significant figures. When we multiply, divide, do exponentiation, you need to know the total number of sig figs for each part, and that'll determine the answer. Except when we add or subtract. Adding subtraction doesn't care about sig figs, it cares about decimal places. So when you're adding and subtracting, you're looking at pure decimal place. So if we're going to add 1.1, one decimal place, to 0.23, two decimal places, our answer is going to have 1. You always do the least amount. So our answer is not 133, it's 1.3, one decimal place. Now, most of the time, 99% of the time, we're not going to be adding and subtracting, except in Dry Lab 1. Most of the time, we're going to be multiplying and dividing. So when you're multiplying and dividing, then you need to look at the total number of sig figs. Okay, so so if we put 125 and 2.1 into your calculator, multiplying, you should get 2625. Let's see here. My calculator cleverly is rounding for me. Why is it rounding too long? If you have a TI 83, 84, you can set it up to automatically round for you. I loaned this to one of my students, and that's what they put in here. I gotta figure out how to figure it out. Okay, let me just do this again really fast. Who speaks Spanish? It's basura.
Oh, okay, I was gonna say, is your calculator in Spanish?
Yeah, 26, 25. Okay, however, 1.25 is 3 sig figs, 2.1 is 2 sig figs, so our answer is going to have 2 sig figs. So we go to the third place, and that determines what the second place will be. Okay, if it's 0 to 4, we drop it. If it's 5 on up, we add 1. So 2 is 0 to 4, so we just drop it. So the answer is 2.6. Now I will go like this. That means 2 sig figs. You can do that if you want. I just do it for clarity. Most people don't do that. I do it. I'm teaching you about sig figs. Okay, so adding, subtraction, this cares about decimal places. Multiplying, division, exponentiation cares about sig figs of each number. Each time we take the least amount. Least amount of decimal places, least amount sig figs in the answer. Except when we're working with money. Money always has 2 decimal places for no net. Regardless of sig. It's just the way it is. It's a huge exception. Okay, so those are the rules we're going to be using when we're working with numbers. 1, you have to know the sig figs. Number 2, you have to know under what application you're using. Whether it's multiplication, division, math, subtraction. Okay, is that clear? Dry Lab 1 practices it a lot. That applies to subtraction as well. And division. Now, the reason why it applies to subtraction is the inverse operation of addition. Division is the inverse operation of multiplication. They're one and the same. One and the same. That's why you treat them sig fig wise the same way. Exponentiation. Same thing. That's a shorthand way of doing multiplication and division. Okay. Now again, Dry Lab 1, you've been doing pages of this stuff, lots and lots of practice. Okay, so
The sig figs, it always is like the least, so I'm a little confused with what I divide stuff because it seems like we ended up 2.6 instead of 2.62.
which is what your calculator says. The calculator is underneath the covers of your calculator, goes to 29 places. Sig figs. Totally useless. Okay, if you're looking for a 2 sig fig number, you go to the third place. It doesn't matter the other 26. It only affects one more. Even if they're all 9, if it's a 2, 9, 9, 9, 9, 9, the 2 is the only thing that counts, not the 9. That make sense? Yeah.
So I've never heard of significant figures until today, but I don't. Using the smaller one, like just the smaller amount of significant figures when we multiply and divide, like why do we do that?
Okay, let me give you an analogy. We have a chain. Chains are made up of links, right? They're all rated at a certain poundage that before they break. So I've got a box of links. Every one of them can hold 100 pounds before it breaks, except one that holds 10 pounds. If I make a chain out of those links, how much can the chain lift without breaking? 10 pounds, exactly. So it's the strongest of the weakest link. In nature, wolves run in packs. In the front of the pack are the elderly wolves, the slowest ones, the sick ones, they're in the front. So they guide how fast the pack can move. Same with sig figs. It's exactly the same thing. It's always the weakest part that determines the overall. Sometimes that's true in life too. With various.
So what you're saying is the wolf that's laid out there is an elderly wolf? Probably.
Probably, yeah. Or died of something. Okay, then yeah.
Didn't qualify. The food above.
Well, first of all, it's 2 sig figs because that's 2 sig figs. Is that?
Oh, so it's sort of similar like that.
Yeah, it goes back up to what number you're using to get your answer. Whatever's smaller between those numbers. Okay, and then, like if it's, your answer needs to be 2, you go to the third sig fig. And that determines what the second one will be.
Okay.
Round up or round down, yeah. Not round down or just drop it. Better? Yeah. Yeah. If I heard you right, you're talking very softly. Okay, one other thing. How many eggs are in a dozen? You all got that right. Is it 12.1? Is it 11.9? No, it's exactly 12 by definition. By definition. Okay, so the sig figs are infinite, not 2. If it's measured, go by the sig figs. If it's by definition, it is infinite. So if we multiply (2.1) dozen eggs. Okay, to multiply that and count here, you go 12 times 2.1, right? Okay, that's going to give you. It's a 25.2. Okay, so we had a yolk in there. All right. So we're multiplying here, right? Okay, so that's 2 sig figs, and that's infinite because it's by definition. Infinite stuff we don't count because it's perfect. It's just by definition. The 2.1, someone counted it and there was part of an egg in there or whatever. So our answer is going to be how many eggs? We're going to have 25 eggs.
And who cares about the 0.2, right?
How many sig figs is 2.1?
2.
2. So your answer is going to be 2 also. 2 infinite. 2.1 is smaller than infinite. I'm going to go with the 2.1. Right? Okay. But our calculator gives us 3 sig figs. We have to convert that to 2 sig figs. That makes sense? All right. Now, one of the things, so on your dry lab 1, you're going to be hit hard with sig figs. The other thing is scientific notation. Now, the purpose of scientific notation is to make awkward numbers less awkward. Now, in this class, we're going to be working some huge numbers and some really tiny numbers. Let me give you an example of some of the numbers. Oops. So is that an awkward number? We're going to be using this a lot in unit 2. That's called Avogadro's number, 6.02 times 10 to the 23rd in scientific notation. So 602, 21 zeros is kind of awkward. So 6.02 times 10 to the 23rd is less, it's still awkward, but not as awkward as that big long number. That's its sole purpose. So if the number is awkward for you, do it, convert it. If it's not awkward for you, don't do it. Now, when you get to your next class, they may have rules on what's considered awkward. And you got to go by whatever they say. But in my class, if you're comfortable with a number, do it. Do it. That works for something as small too. So we have this thing with 14 zeros before the 45. Kind of awkward. Imagine putting that into your calculator. Chances are high that you're going to mess it up. So we're gonna go with scientific notation on that as well. So again, awkward is relative to you. Like,
I can't even read that, it's so awkward.
neither can I. It's quadrillion, something crazy like that.
Yeah.
Yeah, it's crazy. Like 1012. This is awkward for me. Well, I'm not gonna convert it to scientific notation. Leave. Now, for you, it might go, oh my gosh, it's awkward as heck. Convert it. Either answer is fine. Because they're both correct. All we're doing is renaming. Just renaming. So the number, the quantity remains the same. What's different is its name. One's name is less awkward than the other. Quantities are still the same. Okay, so scientific notations in two parts. There's an exponentiation part. And we're using base 10 here. The exponentiation part can be a whole number or an integer or a decimal. Most of the time, like 99% of the time, it's a whole number, but it can be a decimal. Depends what class you're in. Okay, that's one part. Okay, the other part is over here. That is a number from 1 to 9, basically. 1 to 9.999, whatever, okay? Like, let's take this number here. 127 times 10 to the 4th. Or 127 zeros. Okay, we're going to class that as awkward, so we're going to convert it to scientific notation. So this needs to go to a number from 1 to 9, which is going to be 1.27. What did we do to that number to go from 127 down to 1.27? Did it get smaller? Everyone say yes, got smaller by a lot. So we divided to get that number. Dividing makes numbers smaller. So if we divided by a certain amount, we've got to multiply the exponent to make up for it. Because the quantity is the same. So what we do to the other one, we do the inverse operation to its counterpart. Okay, so if we're dividing by 2 decimal places to get 1.27, we've got to up it by 2 decimal places in the exponent. So the exponent goes up by 2. The number goes down by 2. They have to be the same. If they're not the same, you've changed the quantity of the number. So you're going to have some exercises, Dry Lab 1, where you're given an incorrect scientific notation number, and you're to correct it. Okay, 1024 times 10 to the 4th. That's not scientific notation. Incorrect. What's wrong with it?
It's great.
Hmm?
It's great.
Yeah, the 1024 is not a number from 1 to 9. We're going to make it that way. So we're going to convert it. The easiest way, there's 2 ways to do this problem. One way is just write that number out. Now convert it to scientific notation. Okay, decimal points here, we're going to go 1, 2, 3, 4, 5, 6, 7. So it's 1024 times 10 to the 7th. That is the clearest way for students. Now, if you're comfortable with math, we need to go from 1024 down to 1. So we have to divide by 1,000. So that means we have to multiply by 1,000 over on the exponent. So you can do it one step rather than two steps. But if you've never done this before, do it in two steps. Okay, so scientific notation, awkwardness. Sig figs. Whenever in science class particularly, you have to use sig figs, unless it's by definition. Now, on Dry Lab 2, I want you to Dry Lab, I want you to download Dry Lab 2 digitally and print off the first page. The first page is conversion factors. Your Dry Lab gives you conversion factors, but they're very they're not clear as to which numbers are by definition. My version is very clear. I boldface them and italicize them. They'll hit you in the face if you're not careful. The other thing is the metric system, converting back and forth on metric system. We're doing that as well. And that is a matter of see, let me pull up. Yeah, the metric system is in two parts. There's a base unit here. And that's like meters, pounds, liters, base unit. And then you've got a multiplier in front of it. Kilo is a multiplier of 1,000. Mega is a multiplier of what? Like a megabyte is how much? Huh? Million. So this is so if we have 2 kilometers, how many meters is that? Hmm? 2,000 meters. So to go from kilo to the subunit differ by 1,000. Which is smaller, a meter or kilometer? A meter. So when you're in the conversions, the number you get here is going to do what? That gets bigger. That gets smaller. So if you're done with your conversion, make sure that that happened. So the smaller unit always has the bigger number. The bigger unit has a smaller number. Because we're just renaming again. We can't change the quantities. What we do with one, we got to do the opposite with the other. We're going to be practicing metric conversions as well. Okay, that's what I wanted to cover today. Are there any questions about either sig figs or scientific notation or metric system? And again, Dry Lab 1, practice it a lot. Yeah. If there are no zeros in it, just count them. Count the numbers, the digits.
All the digits.
If there's zeros, then you have to throw, you know, well, if it's the beginning, if the end, but the no zeros, it's just count. 2.1.
There's actually 65, but they, so is it 653? It was.
Right. So, but we gotta go to two sig figs in that answer, remember, because it was 2.1. Two sig figs, your answer's gotta be sig figs. So it has three digits in there, so we go to the third place. And that determines what the second place will be. So we went to the third place and it was a 2. 0 to 4, drop it. And we're left with 2 digits, 2 sig figs. Or sometimes you have to go up, sometimes you just drop it, because it's from 0 to 4. And it doesn't matter what's after that. It can be all 9s. Up to infinity, it doesn't matter. The only thing that matters is the third place. Just ignore everything else, because the calculator's only going to give you big old long numbers. And again, that's the only part of what's underneath the covers is 29. I mean, only a lot. So, but you don't care about those other numbers. You just care about 1 plus the sig figs. If your answer is 2 sig figs, you go to the 1 plus, that's third place. Okay? Better?
Yeah.
You're basically saying some like the numbers. That and to be the same, use has the same number.
It's the smaller of the two. It's in sig figs, it's always the, with adding, subtracting, it's always the least number of decimal places. Multiplying, dividing, it's, you look at the whole number of sig figs, it's always the lesser one. Even though in your mind, you believe your calculator. Calculator's a dumb thing. It doesn't understand the concept of precision at all. Unless someone puts in round to 1 place. Okay? All right.